It's my first time here speaking at the Python WebConf, and I'm very excited to be part of a wonderful lineup of speakers. First of all, many thanks to the organizers for having me here and allowing me to present this talk. By way of background, I am a developer advocate at the Cloud Foundry Foundation. The Cloud Foundry Foundation, or the CFF, is a part of the Linux Foundation. We have a varied history of being like an independent nonprofit, and then we recently became a directed fund that's a part of the Linux Foundation. And we found a wonderful home at the LF. And we are an independent governing body that was basically created to administer a lot of the technical and non-technical areas around the Cloud Foundry project. What we also do as a foundation is we work with a lot of other open source teams as well, and we manage a whole raft of open source projects. And one of them is Paketo Buildpacks. So that's what I'm here to talk about today. And the whole idea behind Buildpacks is to provide a very simplified and smooth developer experience. And in today's talk, we're going to see how that really is made possible. Now, by way of a little more background about the project itself, Paketo is a series of build packs that are implementation ready, and they derive from the original build pack specification that is maintained by the buildpacks.io project, which is part of the CNCF. Now, buildpacks.io provides a spec, and Paketo is the contribution of a bunch of like open source maintainers who maintain the actual implementation of the interface and the spec that is provided by the buildpacks.io team. The general sort of umbrella term that governs all of these efforts is what is known as Cloud Native Buildpacks. You probably must hear the word Cloud Native a lot today. And that's because there's like tons and tons of different teams who are applying the term to what they do. The definitions vary a lot, but I guess my rule of thumb for what is and what isn't Cloud Native is, does it containerize? And is the project like open source for folks to pick up and customize? So those are really my two tests for whether something is a cloud native project or not. So Cloud Native Buildpacks is a project that was born in order to help find a balance and strike the right amount of effort that is required by developers and operators. So what we mean by that is application developers should be able to focus on their source code and not worry too much about deployment parameters. And on the flip side, platform operators should be able to focus entirely on keeping systems running and all the lights up, and not necessarily have to, wiggle their way around different things for different languages and frameworks, etc. So when I say cloud native buildpacks, you obviously must be thinking, well, was there a non-cloud native buildpacks, or is there, something else to the story? And so here's like a brief sojourn into history for a little bit about the Buildpacks project and the whole technology itself. So as some of you might know, Buildpacks were originally a part of the Heroku toolchain. So if you recall, like the magical Heroku git push master experience, which would just, take your source code, go off, into the Heroku la la land, so to say, and then just ship your code there and return like a magic link. That's basically a URL endpoint to your app, right? So if folks are aware of that experience, that was basically the result of having Buildpacks. it was Buildpacks that, behind the scenes picked up the source code and transformed it into something on the cloud. So a few years later, when the Cloud Foundry project started, and back then it was by a team at Pivotal, which was like the commercial front for a team that basically, like a company that basically worked around Cloud Foundry. They had their own version of Buildpack. So they sort of forked from the Heroku approach, did like a bunch of things differently. They, in fact, pioneered some of the stuff that we're seeing with scheduling and orchestration and containers as we know them now. Of course, the names were different, the tools were different, the scale at which they were adopted were dramatically, I guess, different. But all of the interesting paradigms and patterns that we see today vis-a-vis containers, container orchestration, scheduling, and all of these advantages that Kubernetes generally seems to profess were all sort of true even back then with Pivotal and Cloud Foundry. So Heroku simultaneously was also developing the same kind of experience for the Heroku platform. Now, of course, they were more closed source and they did not have some of the same characteristics as Cloud Foundry. But then a few years ago, both the approaches sort of converged, and then they decided that instead of doing two independent approaches for Buildpacks, let's first declare, that the specification has to be OCI compatible containers. And then, obviously the deployment to Kubernetes and using them in every sort of vanilla environment which requires containers came a little later. So that was when the Cloud Native Buildpacks project was born. Buildpacks.io is the official home of it. And then there was an implementation that, was done largely by the folks at VMware, but fully open source. And there's like a bunch of different independent contributors and maintainers who help push the project forward. But on your screen now, a summary of advantages for using Buildpacks. There's like a bunch of different things in theory, why they're great. I'll let you, go over this on the website, on the slides and stuff like that. But also in terms of who does and who does not support Cloud Native Buildpacks, like I just wanted to splash this, every possible relatable logo out there, I guess. But like there's a whole bunch of different platforms that are adopting this, and there's also like a lot of new platforms that are being built on top of Buildpacks. So maybe I'll switch to like the demo for a little bit, and then we can go into some more details about what is what. Let me shows like a bunch of windows. Hopefully this is visible to everyone. All right. So basically my demo is going to be one command to containerize an application, and then I'll obviously run it on Docker and show you what is what. So this is a bunch of different sample apps that I have. They're all meant for this audience. Obviously they're Python, but there's like every conceivable platform or language is meant to have an identical experience. That's really the goal with Buildpack. So again, a hark back to the Git push Heroku master experience, where Heroku was able to take your app in whatever language it was, run it on the cloud, and bring you back like a link. And so this is really the same sort of experience that we're trying to achieve here, irrespective of like the platform, irrespective of the framework, and irrespective of where you want to deploy it to. So there's no like, you're not bound to deploy it on a Paketo platform or a Cloud Foundry or a Buildpacks platform at all. So this is independent of the platform itself. And so it has been demonstrated to work for all languages, although I'm sure this audience does not care much for something except Python, I guess. But let's see. So I'm going to start with like a pip environment, like a pip demo. So basically, every you probably would have noticed that every different sort of package manager has a sample, and so there's support built in for all of these different package managers. And if you look at sort of this particular app, there's very little in terms of what the different steps are you need in order to build it. And before I containerize this, there's no additional files that I have to actually write, or so like no Docker file, no set of like scripts or anything like that. So Pack is the CLI that I'm going to use, and it is the CLI that basically supports buildpacks.io, and it will make use of Paketo. So let's just go ahead and build a container, and I'm going to call it PyConf. So I'm going to let this run in the background. Hopefully, there's like a bunch of stuff that are cached and that can be used. But basically, you'll see that there's a detection stage that is going on. There's like a bunch of different things that are going on. But ideally, if I grab any code from an open source available example and I do it, it'll run through a detect phase and it'll find out what is the language that is actually being used. And I mean, I haven't had to specify any specific build packs and things like that. And Paketo is really able to figure out what the language is and make use of the commands and different things in order to run this. So now I'm going to quickly run this container. So this container will boot up, and if I bring up my browser, there you go. So that's my app really, and it's running that container, and it basically serves like a file. So it's pretty basic, but that's really what is going on here. And obviously there's like lots and lots to unpack, and that's going to be the rest of my presentation. So if folks have any questions, please ask them. Don't hesitate to sort of or wait until the end or something like that. By all means, feel free to sort of interrupt and share what you think. So what's happening here really is there's Pack, like I said, the tool that is available. So I'm going to just open that in a new window. And Pack is the CLI that basically provides the builder. And Pack allows you to manage the life cycle of any container that you're building. So one of the things here, as you can see, is this is the build itself, and then you can actually specify different builders and different build packs. So builders are like the base images on top of which the app image is then constructed. And one of the things is that build packs have their images in a very layered fashion. And what I mean by that is they're very composable, and you can individually replace layers from container registries and things like that. And so it's very nifty and not bulky as compared to other ways or other means by which you can build your images. So builder is like the base builder. The build pack is the build pack itself, which is basically like a bunch of different scripts, but it goes through this life cycle, as you can see here, of first detecting the language and the framework. Obviously, there's like an analyze phase, but the detect is like the big milestone. And then based on the code and the different files that it sees, it'll find like a bunch of different build packs to actually perform the build itself. The next phase is the build phase. Now the restore phase that you see here is basically like a result of caching some stuff. So if you have like a bunch of different things to be cached, and every subsequent run becomes faster and faster because so much more caching and other things are available. Now there's a bunch of certificates that get added first, and then the Python build pack sort of kicks off the build, and then pip is involved because that's the package manager here, and then different configuration and different things get assigned. And then the start command is basically derived from the Python start build pack. And then finally, there is like one process that we kick off to actually start the app, which is available as a proc file. So different things are created. There's like software bill of materials and everything, and then that's how the image ultimately gets built. You can obviously use your Docker runtime environment for running the container. You could deploy it to Kubernetes. You could deploy it to any other engine that runs containers, so to say. And the experience is essentially the exact same, and that's really what we want to prove here. And so let me demonstrate this with like another package manager. So this is running using so the package manager here is Poetry. This will be running in pretty much the exact same configuration as we saw earlier. Let's see. Okay, so there's something that will get served. Another Paketo image, I guess, but let's see. I'm also going to try and play to the audience essentially, but try and display this as well, but in a bit. So what I'm going to do is first run through the build. So pack, you can so these are the builders, and like I mentioned, builders are like the base image. So this is on Google's container registry, so GCR. So Google, Heroku, and VMware as Paketo have these different kind of build packs that are available for you to specify as the base image. So Paketo has 3 different base images that it creates. So there's like a tiny, which keeps your image sizes very slim. There's full, that's obviously like has like a lot more dependencies and other things. And then there's like the builder base, which is like a good middle ground. So it has the advantages of keeping the image size in check, but also providing enough functionality for like a variety of languages and frameworks. At present, they're all based on like Ubuntu Bionic. And there's work underway to migrate them to like Jammy Jellyfish very soon. So just in case you're interested, you can deep dive a little more by inspecting them. And I'm just going to run an inspect command on this. So what this will do is allow me to check all of the different layers that are available. So like I mentioned, this is the experience that we want to showcase for like every single language and framework out there. So what happens as a result is support for every, language and framework is actually made available. Now, this is like, these are different groups. So if you notice, one of them is like a Python group. So there's like a bunch of different Python groups. Depending on what's the stack that is in use, one of the different groups will get picked up. And it essentially goes in this order for each different sort of language. So Go is, group 3. Python is group 4. Group 5 is just Nginx apps. Group 6 is Java apps. And it goes like that. And so, different certificates for each of them. All of this is baked inside the builder itself. So now I'm going to run the same thing. So it's essentially pack build followed by this particular image name. And so some of the layers tend to get reused, but also because of the difference in nature between the files that were in the first app and the files that are in the second app. By files, I mean different sets of like metadata files. So like it uses a pyproject.toml here. And so that will indicate that Paketo needs to use poetry for managing dependencies. So that support has been baked in as well. And so you don't have to necessarily specify different sort of package managers as you're building this. Paketo is smart enough to figure out what are the different build packs and build accordingly. So the steps that it goes through are the same. So the detection phase, the build phase, and then there'll be like an export phase that actually showcases how the image gets generated. So let's do the same thing here. Let me just change the and the result should be exactly the same, which is not the most desirable case, but let's see. I'm going to copy this tag. Yeah. I'm going to change it to something. Something else. And the reason I'm doing this is I want to showcase some of the caching and the reuse capabilities of the build process itself. So let's see. Okay, so I'm going to build the same image again. It will go through the exact same steps. So just to sort of just to sort of talk to you about how the layers are organized, is basically, the base OS, which is sort of like, the base image that we had seen. And then the dependencies are managed using one of the different package managers. And then the app is structured as a separate layer. And I'm going to skip through some of these things. So the distinction between having like Docker in the process, which is like the most popular containerization forms, is you have a Docker file that lives along with your source, generating a Docker image that you can then deploy. Whereas with Pack, you basically have the source code, and then because Pack already implements the Buildpack spec, you get an app image. And here are some of the advantages of Paketo itself. It's very it's built to be very agile and small, and it can also be combined to build bigger and bigger build packs, so to say. So here we saw through the history, I did mention that it works for all languages. There's obviously some big questions that people tend to have, which is, who are the folks that are using build packs? And so, like I mentioned before, there's like a bunch of different platforms that make use of them. Are they good for like local and production deployment? They're probably your best choice, because the parity that you get for production builds is the exact same as local builds. And so because it's the same command and the same set of build packs participate and things like that, you have like an assurance of 100% parity between local and production deployment. So finally, one of the other frequently asked questions is, can these images be published to a registry? And the answer is absolutely. So the pack command itself allows you to export it to a registry directly. So if you have like a GitHub registry or a GitLab registry or Google registry or some other registry that is specific to your org, as long as you're authenticated with it, Pack will publish this. And yeah, lastly, the project is like fully open source. Both the Buildpack specification and the Paketo implementations are both open source. I probably have mentioned this more times than needed. Yeah, I'll come to these one or two other questions in just a bit, but we can see here that the build is completed. And it's you can notice some distinction. There was no sort of difference. There was no entry for the analyze phase, but here there is. Restore has like a bunch of different things that it is restoring. Previously, nothing happened. And so the build process itself is way faster. And so if you compare sort of times, this was about 4 seconds. I probably should not have spoken over it. Whereas previously it took like, I think, 20 seconds. So that's like a huge gain in time if you compare that with like different parts of it. And so if you just look at the restore phase, there was nothing, and the analyze phase had nothing. And so this time around, both the analyze and the restore phase really made use of a lot of caching capabilities. And now, just to get this running, hopefully, it works, and my sort of HTML skills are not too bad. So there you go. So we sort of, had an app, changed it, built it again, the whole sort of life cycle. So back to the questions. Does it work, for smaller projects? Does it work for bigger projects? Does it scale? We've had plenty of responses from folks out there who have tried build packs in their environments. Now, there's a couple of maintainers, one from ING Insurance and another one from Bloomberg, both of whom work very closely with the Python community. The Python community inside Paketo, especially. And both of them obviously, have tons of feedback for the build packs. And so insurance and finance is probably like some of like the most scaled verticals. And so they operate um, in a big way, and both of them have you know participated enough for us to believe that Buildpacks is definitely out there, good to scale, and definitely available for your real world applications. So I'd like to show a few more things before we close. So first up, the different phases and the different types of dependency managers that are supported. So you have pip, you have conda. If you don't use a package manager, that's fine as well. Typical applications that we are seeing folks run with this are AI and ML. So a lot of data science folks who do not want to get into the nitty-gritty of maintaining like Python environments and things like that take to Buildpacks like the proverbial duck to water, and they've had some very good successes to report. The next thing I wanted to show you is like the different project pages. So buildpacks.io, which is owned by the CNCF, the Cloud Native Computing Foundation, for those who are not aware. This is the home for the Buildpacks spec itself. So it's the best place to sort of come to learn about the spec and for comparisons with other containerization mechanisms and general information about Buildpacks itself. The Paketo project, oops, you should probably know how to spell this by now, lives at paketo.io. So this is the home for one of the implementations of the Buildpack spec that is available. So this is the home for like all of the Paketo related things. And so, you can sort of see through this very nifty graphic how the different layers are composed and how your app basically gets built. Obviously it says node and npm and stuff there, but it's true for like every single language and framework that we support. One of the other cool things about that I like about both the spec and Paketo implementation is that these are all very composable, in that you can combine like different build packs to get like one larger build pack if you're using different languages and different sets of frameworks in order to build your application, which I guess is true for like every sort of company, I guess, out there. One last thing that I wanted to showcase was SBOM support. So SBOM means software bill of materials. So I'm just going to show that command. How you can view an SBOM. So you can inspect it by using the pack SBOM Python conf demo. Let's see. And so software bill of materials is like a rather big topic in the whole containers space right now. And so if you're interested in like learning more about what are the different components that go into your image itself, then this is very useful. So let's see. Okay, this command can take some time to return. Okay, so let's wait for that to sort of run and get displayed. But essentially you can, I guess, find that same information from using the inspect image command that's also part of the pack CLR. So the idea behind this is exactly what goes into building your app. So all of the dependencies are typically listed in the SBOM itself. And so once it downloads, I'll be able to show it to you. But that SBOM information is baked into Paketo by default, and it's also part of the spec, obviously. So I really like this feature as well. So yeah, these are the different things that I wanted to showcase about Paketo. If there are any questions, I think we have a little over 10 minutes or a little under 10 minutes. So if you have any questions at all, now would be a good time to ask. We're also on Twitter. I'm just going to continue about the project until then. So Paketo.io is the Twitter handle. So please find us here, reach out to us if you have any questions or about Buildpacks, the overall experience or what have you. There's also like a big Slack channel where the whole community gathers and speaks to people. So you can join the community there and find a home for all your questions, I guess. Otherwise, the whole project is open source on GitHub, like I mentioned. We welcome contributions to our GitHub through our GitHub org. So open PRs or file bugs if you find them. Throw in some discussions and things like that. There's a working group meeting that happens for the community. So the timing, the Zoom link, and all of the different information is available here. Past meetings are uploaded on YouTube. So if you're interested, you can check those out too. But we'd really appreciate if folks can, stop by and start contributing to the Python sub ecosystem within the larger, I guess, Buildpacks ecosystem. That's everything I had for today. Hopefully, folks were able to learn something from it. And yeah, I'd really appreciate if you can stop by the community initiatives that we have and share any information you have over there. Thanks again to the organizers for giving me the stage, and hopefully I get a chance to present in the years to come as well. Bye-bye.